Alright, in this video I'm going to be going through how to solve bridge problem 2 from the homework, and you guys can check to see if you did it right based on what I do in this video. Okay, so first thing I'm going to do is I'm going to start off by labeling each of my points. So that's going to be point A. Over here we've got point B, C, D, E, F, and G. Alright, so it's important to label your points so that you can keep track of where you've been and where you're going, and so you guys can know where I'm talking about. Alright, so the very first thing you've always got to do is you've got to label your reaction forces and then find those reaction forces. So at the pin over here at A, there's going to be two reaction forces. A vertical reaction force I'll label RAY, and a horizontal reaction force I'll label RAX. There are two forces at the pin because the pin constrains in two directions, meaning that it's got to exert a force in two directions. The roller, in contrast, only has one reaction force because it only constrains in the vertical direction, so it has a vertical reaction force and nothing else. Alright, so now the way that we solve for our reaction forces is we start off by ensuring that the bridge is in rotational equilibrium, meaning that all the torques cancel out. And to do that, I've taught you guys to make a table to do so. So we've got clockwise torque on one side, counterclockwise torque on the other. Alright, so now when solving for this to find a torque, it's force times distance from the pivot point. The pivot point is always taken to be the pin because it is where the bridge is pinned down, obviously. So that means the only two forces that are going to cause torques are the ones that are not near the pivot point, so that is RBY and this force up here at point G. So starting with the force up here at point G, because I actually know what it is, it's a 700 force. So that's going to be the force aspect of it. And now we also need to figure out what the distance aspect of it, and the distance is always the distance perpendicular to the force. So the force here is horizontal, which means that we're going to take the vertical distance, which is 15. So we use 700 times 15. And that is I forgot to mention, I put that in the clockwise torque section because if you imagine how this is going to turn the bridge, it'll turn it that way, which is the way that a clock goes, that's clockwise. Alright, so now we've got only one other force left, which means it must be going counterclockwise. Let's check to see if up does that. Up would turn it that way, which is indeed counterclockwise, so it is going up, and it needs to be whatever RBY is, multiplied by the perpendicular distance, which, since this is a vertical force, must be the horizontal distance of 5. Okay, and these two things must be equal to each other, so that means that 700 times 15 is equal to 5 RBY, divide both sides by 5. The 15 and the 5 cancel, leaves 3, and you get that RBY is 2100. So we'll put that there. All right, one force down, two reactions to go, and I don't need to really do any fancy tricks to find these two reactions. RAX needs to be canceling only one force, which is this 700 force up here. They need to cancel because otherwise the bridge would be moving left and right, and it can't be doing that. So in order to keep this bridge from moving left and right, if we have a rightward 700 Newton, 700 whatever force going on up there, that means that we need a leftward 700. So that means this arrow is actually going to the left, and it is 700. And then similarly, the ups and downs have to cancel. We have an up of 2100, which means that RAY is actually a down, and it's a down of 2100. All right, and those are our reaction forces all figured out, and we can start figuring out the member forces. So now we need to figure out all of the individual members on this bridge. There are several of them, but it won't take all that long to find them if we just have a plan. So the easiest thing to always do is pick the areas where you know something, but there's not too many members. So the easiest one then would be B, where we know a thing, and there's only two things that we don't know. If we were to pick A, we know two things, but there are three things that we don't know. That's too many things to not know. So we're going to go ahead, we're going to start at B right here, so that's what we'll be doing. I'm not even going to redraw B, we're just going to talk about it because it's actually fairly obvious what the members are. So this member right here isn't canceling any forces on the other side. There's nothing over there. So that means that this member must be 0. It's not canceling anything, so it can't be exerting a force. DB, on the other hand, is canceling out this 2100 force, which means it is also a 2100 force. And since 2100 is going up, this force must be going down, which is pressing into the joint and makes it a compression. So BD is a 2100 compression. Let me draw it sideways because it looks better. All right, so BD is a 2100 compression. Okay, so that's two members already solved. Now we can go ahead and come over to our other reaction area. So we can come over to A here. Now I'm going to redraw A, because this one's a little more complicated. We've got a 700 that we already know going this way. We've got a 2100 that we already know going this way. We have 0 going this way, so I'm not even going to bother drawing it. And then we've got a 45-degree angled unknown force that we're going to assume is going up and to the right, and that is a D. And then we have an unknown going up, and that is a C. So that's this member and this member. Okay, so now if we look at this carefully, there's only one force that's drawn that could be canceling this 700, and that is this unknown AD. So that means that if I were to break AD down into a rightward force and an upward force, its rightward force needs to cancel 700, which makes it obviously 700. And since this is a 45, 45, 90 triangle, that makes the upward part 700, and that makes AD itself 700 root 2. So now I can come up here to AD, and it is 700 root 2. It is going up and to the right, so that means that it is a tension. Okay, so now I'm done with that triangle, if it'll let me erase it. Okay, and I can also erase this, and I'm going to redraw out its parts so that we know what we're dealing with. We've got 700 going that way now, so these are canceled. And we've got 700 going up. Those are the two parts of AD. So now it should be pretty obvious what AC has to be. It needs to cancel the rest of 2100, which makes AC 1400. So we can come over here, and AC is 1400. It is going up, which means it's pulling on the joint, so it's a tension. All right, great. So we are done with joint A. Erase, there it goes. Okay, so now I'm just going to move on to the next closest area that looks pretty simple. So this joint here that I somehow erased the label of, it is joint C. Okay, so joint C here, we don't need to redraw this. There's no left and right forces whatsoever, so this is automatically 0. There's no forces to cancel. That means there can't be any forces in the left and right direction. And CE here must be a 1400 up to cancel the 1400 down on the tension here. So that means that we already know what CE is. It is a 1400, and since it's going up and pulling on the joint, it is a tension. All right, now most people will be tempted to come over here to F, but we literally don't know anything about F. We could say one thing about F, but we wouldn't be able to answer all of F, so I'm going to go ahead and not do F yet. I'm going to actually come up here to G, where we know one thing and don't know two things, so it's actually fairly easy to solve up here. So I'll go ahead and redraw G, even though it's fairly simple. So we've got G. All right, so G has a 700 that we know going this way. It has an unknown going this way, and an unknown going this way. This is EG. This is FG. Okay, so now there's only one force that can be canceling the 700, and that is this diagonal force here. So that means that that diagonal force, if I were to redraw it, looks like this. It has a leftward component and a downward component. The left part must be 700 to cancel the rightward 700, and the downward component must also be 700 because this is a 45-degree angle, and that makes this 700 root 2. So I can come over here and label it 700 root 2. Because it's going down and to the right, that's pulling on the joint, so that is a tension. Okay, so that one's taken care of. I can erase it and draw out its parts. We got 700 this way, which is why these cancel, and we've got 700 going down this way, which means that FG needs to cancel the 700 down, which means it's actually going up, and it's got to be 700 going up. So that means that this is 700, and since it's going up into the joint, it's a compression. All right, G taken care of. Now we can come to F. If we've got a compression of 700 here, we must have a compression of 700 here to cancel it. And we've got nothing in the left and right direction, which means that this is automatically 0. Right, so that is almost everything. We've got one diagonal force left to go. I can either find it by looking at D, which looks like it's a little bit busier than our alternative, which is E over here. So I'm actually going to go over to E in order to solve for that one last unknown. All right, so let's redraw E over here. So here's E. It's got an up and to the right that we already know is 700 root 2. It's got an unknown down and to the left, and it's got a 0 going to the right, which I'm not going to bother to redraw, and it has a 1400 tension, which means it's going down, so 1400. Okay. So I'm going to redraw the angled force as two parts. So it's got 700 this way and 700 this way, which means our unknown here, which is ED, must be broken down like this. It must have a, first off, it must be going the other way because it's got to cancel an up and right, so it must be going, it is canceling this 700 and this 1400 going down adds up to a 700 down, so it's canceling a down and right, which means it must go up and left, so it'll go like this. And it must have 700 to cancel this one, 700 to cancel the leftovers of this one and this one. What's left over is 700 down, so it's got to have 700 up, which means it is 700 root 2, and it's going into the joint here. So now I know that the answer is 700 root 2, and it's a compression. All right, so let's clean that up. This is our full and complete answer. Sorry, let me get rid of all this stuff on the side so I can zoom out for one last look. All right, this is our full and complete answer to bridge problem 2. Please let me know if you have any questions remaining, and I'll see you in the next video.